last class we talked about sinusoidal functions and their graphing. The general form of sinusoidal functions are given below. All right, a equals y equals a sine bx minus c plus d, or y equals a cosine bx minus c plus d. Now, they're all called a cosine or cosine. They're all called sinusoidal functions, right? They're called sinusoidal functions because sine and cosine is just displacement of the other ones. Okay, so they are, if you move, take a reflection or something like that, and sine and cosine can be the same, or it can be the same. These functions can be rewritten as a sine in the brackets, b x minus c over b in parentheses. All right, so and y equals a cosine. All right, similarly. So for this one, we have a is the absolute value of a is amplitude. 2 pi over b over absolute value of b is the period. C over b is the phase shift. All right, it's a horizontal displacement of the basic sine and cosine function. And the vertical shift is d. Our vertical shift is midline is called y equals d. Okay, so now we can determine all of these values if given a function, right? If a given function, we can determine all these values. That's no question, no problem. We did this one pretty well, right? Okay. Well, the question comes when we want to determine the formula of a graph, right? Of a graph. I think many of us, all right, are confusing about this example, and also I can tell, especially you guys are struggling from this one, including me. All right, I followed the textbook, but the textbook really didn't show the general step to do so. But I think there is a better way to do to find these ones. So I want to share with you. All right, so let's start with this example again, and I'm going to show how to use the GeoGebra. All right, so GeoGebra to solve this type of questions in GeoGebra. Okay, so now if you don't mind, can you please share open GeoGebra? All right, we're going to do this. Okay, let me add another page here. Sorry, is internet issue or not? It's coming up. Oh, come on, not doing work. Okay, all right. So this probably is better to do. Okay. Sorry, so slow. Another one maybe. Okay, I think that's enough. All right. Okay. Finally. Okay. Anyway, so we got this one. All right. So this is basically what we have here. All right. Okay. Delete. Maybe it doesn't work. Okay. So consider this one, right? Consider this graph. Okay. We want to determine the formula for the cosine function in this graph. Okay. So how can we do this? Now, since we are trying to determine the cosine functions, right? Since we're going to start with the cosine function. Now, everything else will be the same. All right, so we are going to do what? We're going to do identify the midline, the period, and the amplitude. All right, the amplitude will be exactly the same. All right, will be exactly the same. All right, so we have done that. Step 1, 2, 3. Right, step 1, 2, 3 are the same. All right, so you can order doesn't matter. All right, the midline. Step 2 is the period. Step 3, amplitude. All right, so these will be exactly the same. All right, you determine these ones. But in determining the equation, step 4, we're going to use GeoGebra. All right, we're going to use GeoGebra instead. The idea here is, okay, the idea here is, since it's asking for a cosine function, right? Since it's asking for a cosine function, what we can do is we are going to start with a cosine function, a basic cosine function, and make some shifts or squeezeness, compress or enlargements, some transformations, such that what it became this shape. All right, let's see what do we mean. All right, so 1, start with cosine. Right, start with cosine because it's asking for a cosine function, right? So we start with the cosine function. Now let's just graph. All right, have the GeoGebra ready. Oh. That's prettier. Okay. Well, anyway, well, you want to start with the cosine function, right? And then step by step and come up with the function. All right, come up with the function. Internet is not doing well. Okay. I have this opened before the class. Okay. What's going on? Okay. Have you guys got it ready?
Mine's open too.
Okay.
We can share our screen if that's will be help better.
Maybe it's better to desktop download it instead of running on the web. That might help. Okay, but it's just internet pretty good, pretty strong signals. Yeah. Okay, well, let me just function in the in there. Can we input?
Could that just be y equals cosine x?
Yeah. Sorry.
Is there any difference with f and x?
Calculator.
I'm just want to make sure the graphing calculator gives the same answer, right?
Yeah.
Okay.
That's right. I mean, okay. And the graphing calculator is will have okay. That's troubling. So that anyway, I'm very sorry for this one.
Okay.
But I will have this desktop ready. Taking too much time to load. Sorry for this. Okay.
It's okay.
Okay. Now, okay. All right. All right, let's do this one. All right, determine the equation for sinusoidal function in this curve. All right, in this curve. Or okay. Anyway, so for this one, do this one solution here. Okay. Solution, right? So for this one, it's called for like a sinusoidal functions, right? So we can say, how do you think? We may start with say sine. Right? Let's show a function with sine functions. Right? Let's show that this can be, we can use sine or cosine, but let's use sine. All right, let's use sine for this one. Now, for sine function, we know that this one, right, from the graph, we know the what is going to be the period? I believe it is from 1 to 7, right? 1 to 7, right? That's a whole period. Yes. Okay, 1 to 7. That's a whole period. So the period is 7 minus 1 equals 6. All right. So this is the period. The amplitude is okay.
Max over min goes negative.
Amplitude is what? 1 minus 1/2. 1 minus negative 5 divided by 2, right? So that is 6 over 2 equals, sorry, yes, okay. And then the what?
Midline.
The midline, right? The midline is y equals what? I believe
-2.
-2, yes. Y equals -2. Okay. So now the period is 6. We can say this implies what? 2 pi over absolute value of b equals 6, right? Now, which is absolute value of b equals 2 pi over 6 equals pi over 3. Okay. Now, the amplitude is 3 implies the absolute value of a is 3. And this one implies what? B equals -2. Okay. Then we would select, all right, B as positive. All right. As positive pi over 3. Okay. And for A, okay, for A, now we should see what? We should see some okay, for sine, right? We need to know something about sine. Okay. So for the sine curve, if you know, if you remember, it is something like this. It is something like this one, right? This is a sine function. It goes through 0, you know, it goes up and it goes down, right? So for A amplitude, all right, we see that around 0, it is increasing, right? It is increasing. So we may choose, since it is increasing around 0.0, so we may choose what? We may choose A as positive. As positive 3. Since the function is increasing near 0. All right, around x equal to 0, it is increasing. Okay, so then we have what? All right, so we will have some functions here. All right, so then we are going to have, then this function is after these ones. All right, so we're going to apply these changes. All right, now here's the GeoGebra we will have. All right, so from start with y equals sine of x. Okay, start with sine equals sine y equals sine of x. Now what we are going to do is we are going to apply these ones. All right, so we know that the period is 6, right? The period is 6, so we need what? B is pi over 3. All right, so considering the period, okay, period equals 6. All right, this one we will change to what? Y equals sine of pi over 3 x. Okay, this is our first step because the period became 6. So now after after adjusting for the period, we have a function like this one. Does that make sense? Okay, and then let's say amplitude equals 3, right? Amplitude equals 3. All right, so we need to do this transformation. If the amplitude is 3, so we choose A is what? A is positive 3, right? Okay, so that A is positive 3. So what we do is A equals 3 sine of pi over 3. We got this one, right? After adjusting for the amplitude. Does that make sense? And then the midline. Y equals -2, right? Y equals -2. So by adjusting that, equals 3 sine pi over 3x minus 2. Yes? Okay, so you can see that, all right? You can start from y equals this one, adjusting for the period, adjusting for the amplitude, adjusting for the midline, right? So we come up with a function like this. Yes? Now, this function will look like what? Will be, okay, will be centered at, okay, will be, I really wish I can have this. Okay, nice. Okay. All right, so now let's just do this. All right, let's just using GeoGebra and see what we mean by this. Okay, finally, come back. Okay, so let's just draw the graph. All right, so what is the thing we just come up with, which is 3, right? Sine what? Pi over 3 times what? Times x. And minus 2. You see what I get? I got something like this one, right? I got something like this. Now, consider the original curve. Like by comparing this curve, comparing this one with the one we have on the textbook. Do we have any shiftings, right? Shiftings. Now, one thing here, I changed the setting in GeoGebra. This one goes through. Okay, well, I better better do this one. What is the okay? Now this one is centered at what? Okay, well, one thing I need to do. All right, so I need to change this setting, and for the grade here, especially for x, here I change it back to 1. Okay, now it's going to be better. All right, now it's going to be better. All right, so now this is my what? This is my this is a function fx. This is the function here. You see this? This is this one, right? This is the function shown in GeoGebra. Do we have any problems with this one?
It needs to shift to the left, to the negative side.
It needs to shift by how much? Can you see that or not?
Maybe about a third.
Maybe by 1/3. That's not a good one, right? So we need some number that is specific, right? So now you can see that well, this one you need to determine the exact shiftments, right? So from 1 is the absolute 1 here is the top value, right? So at 1 it reaches the extreme value on the top. So we need to determine, okay, so what is the top in this one? What is the top value in this one? So for sine, right? So you need to determine the value at this point, right? So where is the top extreme, right? The nearest extreme is here, is between 1 and 2, right? You can see it's between 1 and 2, correct? But we want to determine what exactly it is. What is going to be the x value? Give us the largest value. You need to know what is the sine, right? So sine of what reaches the maximum? You remember that? The sine in a singular term, right? Sine is the y-axis, and it goes to what? The maximum 1. Right? Sine function is the maximum has 1, right? The maximum of a sine function is 1. Is it right? Okay. So at which angle it is 1?
Pi over 2, or 90 degrees.
Sine pi over 2 is 1, right? Sine pi over 2 is 1. So that is the point where it reaches the largest value, right? So similarly, for our function here, we need, right, this one reaches for this function in our GeoGebra, all right? We want to identify at which point it reaches the largest value, right? So we need what? We need x sine pi over 3 times x equals what? Pi over 2, right? So that is the point where y equals 1, right? Okay, we will change this one, okay? This is the point if this one equals 1, so that's the point. Okay, let me just show you. Now, at this point, y equals 1, right? The largest value of function is 1. So therefore, we have this one equals 1, right? That's going to be the largest point. But the largest point is attained at what? At if what? If 3 pi over 3 times x equals pi over 2. Yes. Now this times x, times x. This implies what? X equals what? Okay, sorry. Just rewrite this one. Okay. Okay. By checking the graph of this one set, all right, pi over 3 times x equals pi over 2, right? So this it implies if we multiply 6 over, well, it's pi over 3, 3 over pi, 3 over pi, 3 over pi times pi over 3 times x over pi times pi over 2.
Yep.
Yes? Okay, so here 3 and 3 cancel out, pi and pi cancel out, and pi and pi cancel out. So x equals what? 3 over 2. Yes? Here x is 3 over 2. Does that make sense? Okay, so which means we found the exact here. It's between 1 and 2. Actually, it is 1.5. It's right in the middle of 1 and 2, right? It's pi over 2. It's 3 over 2. Okay, now, so in order for the maximum to be at 1, right? We need to shift it from what? To leftwards, right? By what?
3 pi over, or 3 over 2.
No. No. This one is 3 over 2, but this one is at 1, right? So the distance from 1 to 3 over 2 is what?
Okay. Half.
A half. Does that make sense? Now,
Okay.
here is what we want to argue. All right. So, and then that is the value occurs x equals 3 over 2, right? At 3 over 2. That is, the first maximum value occurs at x equals 3 halves. Okay? Now, I have another page. Okay, let me just do this one here. All right, so occurs, and I'm going to do this one here. Since what? The first maximum of the function of the original function occurs 1, right? At x equals 1, as we can see, right? It is goes at 1, right? So that's the maximum at 1. So we need a leftward. Fifth shift by the size of what?
Professor Luke, I have a question about one thing. Like in that page, you wrote in the bottom, it says that is the first maximum value occurs at x equals 3 over 2. And then in the box, it said the first maximum value occurs at x equals 1.
Oh, yes. Well, here is original function. This the first maximum of after the midpoints, right? So we are in the processing of what? We start with sine, right? After adjusting for the period, we got this one, right? After adjusting for the amplitude, we got this. After adjusting for the midline, we got this one. Or it's better to say this, all right? Starting with y1, y2, y3, and now we are at y4. How about that? Okay, now the first maximum value of y4. Okay, this is going to be better, right? Okay, say the first maximum value of y4 occurs at x equals 3 halves, right? But the first maximum value of the original function, as we can see here, right? So this one occurs at 0.1. So we need a leftward phase shift by phase shift of y4 by the size what? That's going to be minus what? 1, right? So which is 1/2. Yes? Okay. And then what we need is doing the shifting, right? Doing the shifting. So here we go, right? We do the shift, leftward shift. Left shift of 1/2, right? Equals what? Now be careful. This leftward shift 1/2 is using. Okay, so what's going on? Okay. All right. Here we go. All right. So what I mean is this is what? Oh gosh. Okay. So the leftward shift is based on. Okay. Just 1 second here. Okay, this one. All right. So this shift, we need to use what? We need to use this form instead. Because what? C over B, by definition, is the phase shift. Yes? C over B is the phase shift. So when we write in the function, we need to use this form instead. All right? A sine B in the parentheses, x minus the amount of the shift. Yes? Okay, so the shift is not a C, it's a C over B. Yes? So we need to use what? The second line, the rewritten form, right? So this form to write the shift. Okay, so now let's come back to the function here. All right, so y5 equals 3 sine in the bracket pi over 3 in the parentheses. All right, so it's a leftward shift. So it should be C should be negative. Yeah, the C over B should be negative, right? So it should be what? X minus negative 1/2 because it is a leftward shift. Yes? So x minus negative 1/2. Close the parentheses, close the bracket, and minus 2. And we can simplify this one. Right? This one equals what? 3 sine in the bracket here. Pi over 3. Now here become x and minus 2. Yes? Okay. You may want to do one more step and write it in, it's sine in the standard form here. Sine is a pi over 3x, and pi over 3 plus pi over 6, and then minus 2. All right, so you can write it in this way. Okay, all right. Sorry, just a small space here. 3 sine pi over 3x plus pi over 6 minus 2, right? That is the final answer. Okay, that is the final answer. Now, basically, this is what we do. All right, basically this is what we want to do using by using the help of GeoGebra. All right. So firstly, we found the period, amplitude, and midline, and determine these values, right? And then what we do is we start with y equals sine x. All right, changing for the period, changing for the amplitude, changing for the midline, and we got a function here. The final step is to determine the shift, right? Is to determine the shift. Now, when we are doing so, we can use GeoGebra to help us firstly get a visual idea, right? How it is, how it looks like, right? So fx equals this one, and by checking this one, we need to determine the amount of shift it has, right? It has. Now, one thing we can determine is, all right, is the top point, comparing the first leftmost or the rightmost top points, right, or the bottom points, or the some midline. Okay, so whichever comes easy to you, right, or easily recognizable. Okay, so for this one, we can see that from, you need to check both, right? For this one, we can easily see that the top point occurs at the original function, right? The top point occurs at 1. So we can just say, all right, so we can just use them to comparing the top points. If we can find the top point in the in Y4, right, in Y4, okay, and then the top point can be just moved slightly to the left, right? So for this example, it's slightly to the left, right? So you can determine where it is located by finding the maximum value, right? Setting what? Setting this power 3 times x equals power 2, finding the value for x. That is where it is located, the maximum value, right? And then by comparing the two locations for the maximum values of y4 and the original function, we can see what kind of phase shift we need. Yes? So for this one, we need a leftward phase shift of y4 by 1/2 to get the original function. Okay, so leftward shift is negative 1/2. So by plugging the rewritten form, right? The rewritten form, and we can simplify it and get the function. Okay, all right, very good. Now, why don't we just solve this one for sine? Or instead, we did it for cosine, right? How about sine? All right, let's just do this one for sine this time. Okay, so see if you can find this one using sine, right? I think 1, 2, 3 are good, right? 1, 2, 3 are good. But we're not doing cosine now, so we may just change this one, right? We may just have to change these ones. Using the new method, all right? So can you use the new method to find out a sine function of this?
Do we have to switch the A and B signs to negative or positive?
They're the same.
They stay the same.
Yeah, these ones will be the same. All right. So for this one, is, the midline is the same, right? 2 pi b is the same. Amplitude is the same. And because they are the same sinusoidal function, sine and cosine are both called sinusoidal functions. 1, 2, 3 are given here. So we start with what? Y equals sine of x, right? So y1 equals sine of x. Now we need to adjust that. So that's y2 plus 2. And then we do another one, is for period. Period doesn't change, right? It's the same, right? Period equals 1, equals 2 pi, so it doesn't make any difference. So y3 is plus 2. Yes? Now we see if we need to do anything about the amplitude. amplitude seems, again, nothing to do, right? So we just say, okay, y4 equals sine x plus 2. Yes? Now, do we need any shiftment? Okay, so here you can see, all right, you can see here you want to identify some characteristic points, right? For this curve, we know that the midline at the point 0, right? It is 2. Yes?
Mhm.
So let's just draw the function of y4 in the GeoGebra. Okay, so got an idea of what it looks like in this function. Okay, so you can delete this one if you want to. Okay. Okay, can you draw a function? This one, it is sine of x plus 2, right?
Mhm.
You see, this is what it looks like. Now it seems like for y equals sine x plus 2, the at point 0 it is goes through 2. Yes.
Mhm.
So it seems like, all right, we do not need any physical horizontal phase shift as well. Yes, it's the same.
Mhm.
So now we can see by comparing y4 the graph of y4, right? Let's see that. And the given one, and the given figure, no horizontal shift is needed. Yes, no physical shift is needed. So therefore what?
Our final equation is sine x plus 2.
Yeah, once y equals simply sine x plus 2.
Mhm.
Easy, right? Okay, this is very easy. All right. See, this is by showing, okay, this is how this graphing, all right, can help us using this step-to-step, all right? So midpoint, midline, the period, amplitude, after determining that, we can just change it, right? So the midline, adjusting for midline, adjusting for period, and then amplitude, and then we finally determine the physical or the horizontal shift, right? So by comparing the graph of y4, what do we get after midline, period, and amplitude? By comparing that with original given graph, right, we can determine the amount of phase shift and the direction, right? And then we can determine the value, but using the rewritten form, all right? Be careful using the rewritten form. Okay?
Okay.
All right. Okay, now let's consider an application of this example, all right? Say, Garrett, can you read for us, please?
The London Eye is a huge Ferris wheel with a diameter of 135 meters. It completes one rotation every 30 minutes. Riders board from a platform 2 meters above the ground. Express a rider's height above ground as a function of time in minutes.
Okay, very good. Thank you. All right. So here is, say this is a ground. I have large wheel, right? So, all right. Right, so something like here, right here is the bottom. Now we know that what we know
Okay.
is the platform 2 meters, right? So here is 2 meters, 2 meters, right? So the diameter is 135. So what is the radius?
That
Is 135 over 2, right?
67.5.
67 and a half, right? So meters, okay? 67 meters. So what is the center the value? What is the height of the center?
69.5 meters.
Yeah, so the height of the center is, all right, 2 plus r equals 2 plus 67.5. All right, this is the height of the center. Okay, now let's say that it completes one rotation every 30 minutes. Riders board from a platform of 2 meters above the ground. Okay, above the ground. Okay, so what we need is, now they board at here, right? So they board at the bottom of the wheel, right? So it's a 2 meters platform. So initially it is the rider's height is 2, right? Initial, correct?
Yep.
And one rotation, okay, let's say that at time, if we let t be the time, after boarding, right? After boarding on this, right? T is this. So let's consider this one, right? I'm going to have, okay, let me just do this one, make it clearer here. So let's say that this angle is alpha. Let's say this angle is alpha, all right? This angle is alpha, then the height, if we draw a horizontal line here, this will be what? A right angle, right? This is going to be a right angle. Now, let's say that alpha be the angle the person made, right? The person made, the rider made, all right? So with after in time at time t. Yes, at time t. Okay. Now, since this rider, this wheel will rotate, right? How long is rotate? One rotation is 30 minutes, right? So if it's in t minutes, then what is going to be the angle, right? What is going to be the angle? All right. So we need to know the speed of the rotation. Yes. In 1 minute, what is the angle it made, right? So since one rotation, that is 2 pi, right? The radian degree is 2 pi, all right? Takes 30 minutes. The angle in 1 minute is what?
2 pi divided by 30.
It's going to be pi divided by 15. Yes. That is going to be the speed, the radian per minute, right? In radian per minute. So That's a pi over 15 per minute. Okay. Now, then alpha equals what? Hence, at time t, alpha equals pi over 15 times t. Yes? Times t. Right? So that's going to be the amount of the angle counterclockwise, right? Counterclockwise is made. Okay? So from the initial. Alpha is pi over 15 times t. Yes? Okay, very good. Then if alpha is pi over 15 times t, then, okay, here's alpha, and then we know what is the height. We want to find the height, right? So after t, it is at this point. At this point, what is the height of this one? It is, all right, we need to find a general formula for this, right? It seems like the r is the radius. This is the radius. It doesn't change. It's always there, right? And r times cosine of x, cosine alpha, is this distance, yes? Right?
Right.
Okay. So the height is basically what? It's basically the center at the center minus, right? Oh, okay, you have 2. And plus r is the center, right? The center minus this length is going to be the height. Yes? All right. Not page. But, okay. Okay, just do this. Okay. Okay. All right. Let's do this one. So the height of this this person is basically the height of the center minus this distance. Yes. Height of the rider is what? The height of the center minus r times cosine alpha, right? Does that make sense? Okay. All right. So therefore, we have, okay, sorry, I changed this one to this place. Okay, hence, okay, now the height, say h of t equals, all right, we know that the height of the center is 2 plus r, 69.5. Yes? 69.5. Minus r is 67.5, right? Radius, 67.5 times cosine of alpha. Now alpha is what? Alpha is, as we can see, is pi over 15 times t. Yes? Okay, so therefore it is so that's it, right? That's going to be where what? T is the time, right? T is the time. Or T is the time. Okay. So at then can you find, based on this one, we can see that what is the tallest point, the highest point it can reach?
137.
137. Yes, 137. 137. Well, it's going to be what? This one plus this, right? Yes. Okay. So so that is when what? When cosine the minimum. Well, here's a negative, right? Minus this one. So when cosine this one equals -1, right? So we can see from this function here, it rotates, right? It rotates. So it will go 3 minutes up, and then after 15 minutes, all right? So you remember h of t, the maximum value of ht occurs when what? When this cosine equals what?
-1.
It equals -1. Yes. Okay. Very good. So when will this one equals -1? All right. So it is power 15 times t. It must be positive, right? It must be positive. Equals pi or 3 pi or pi plus 2k pi. K is 0, 1, 2, da, da, da. Now, does that make sense or not? Okay. It should be like this, right? Because if you are hanging on there forever, right? So this will be what? It will reach the top in 15 minutes. Yes? Half, because in 30 minutes, it is a full rotation, right? 15 minutes, it is go from the bottom to the very top. That's 15 minutes. Yes? Now, 15 minutes, then if you don't drop, if you don't leave this wheel, and you wait another 30 minutes, you got a top again, right? So it's going to be 15 plus 30, right? 15 plus 60, and 15 plus 90, right? Every 30 minutes afterwards, you reach the top. Yes. So that's basically what we do here, right? So it is when t equals, okay. So if you can solve this one, all right. So if it equals pi, all right. So you can just multiply pi 15 over pi times this equals what? 15 over pi times pi plus 2k pi. All right, so here 15 and 15 cancel out, pi and pi cancel out. That's just a t, right? Equals what? Now pi and pi cancel out. That's 15 plus 15 times 15 over pi. Okay, let me just do this. Right. Let me just equals plus 15 over pi times 2k pi. Yes. Now pi and pi cancel out. Here pi and pi cancel out, right? So this one equals what? 15 plus 15 times 2, that's 30. 30 times k. Right? So k is 0. When k is 0, that's 15. That's the first time it reached the top, right? And then when k equals 1, that's 15 plus 30. Correct? So 15 k equals 2. 2 rotation after 15 minutes, 2 rotation after 15 minutes, right? So and so on. Okay, so that's the height is a function of cosine, right? So this is the application. Okay, very good. All right, so for questions like these real applications, we need to know what we mean by firstly sketch the graph, right? Firstly sketch that, and then try to use cosine and sine and geometry, right? The red triangle geometry to represent the question, the amount of interest, right? So for this one, we are trying to find the rider's height, right? So for the height, we need to find a function for it. We need to find a function for it. So for this one, we can find the function. All right. Now you need to create firstly t. So in t, there is going to be an angle. Whatever the angle is, you need to express it in terms of t, right? In terms of t, because it's a function of time. Right here is a function of time. So after we got this alpha here, do your analysis of geometry, and then represent this height as a function, right? Now, because it involves circles, right? For this one, the center stays here. The center always stays there, right? The height of the center doesn't change. Now, that's a fixed point, right? So we want to utilize that, right? And then another one, by this one, we realize that now the height is just the distance, the difference between the height and this one. Yes? Okay, so that's it. Okay, now we're going to move on to chapter section 2.2, graphs of other trigonometric functions. All right, so let's do this one, graphing of tangent x. Okay, so as we know, tangent x equals sine over cosine. All right, but since the cosine is at the bottom, cannot be 0. Yes, cosine cannot be 0. Now we know cosine, if cosine is not 0, which means what? Which means the x coordinate in a singular in a circle, right, cannot be 0. Yes, the x coordinate cannot be 0. Now if you see this, right, so for which of them the coordinate, the x coordinate is 0? I believe this one, right? The coordinate is 0, and this one, right? The x coordinate is 0. So here, it represents pi over 2, yes? And bottom is 3 pi over 2, correct? 3 pi over 2. Now, pi over 2 is 0 plus pi over 2, and the 3 pi over 2 can be used pi plus 1/2, yes? Pi, okay? We can just write these two in together. Basically, it is either starting from 0, you add pi over 2, or you start from pi, add pi over 2. Yes? Now, if you do a full rotation, it is the same, right?
Right.
After full rotation, the x coordinate becomes 0 as well. So basically, it is either either from 0 to plus 1/2 or pi plus 1/2. We can write it as what? K pi. All right. So here k can be 0. K equal to 0 is from 0 to add 1 pi. But if k is odd, it's starting from pi. Yes. Okay. So basically, it means cosine x cannot be 0. So x okay, so this is the same, all right? Now another thing is about the tangent, all right? Tangent is sine over cosine. The period of the tangent function is pi instead. This is not what? This is not 2 pi, all right? Tangent is pi. Okay, tangent, the period of tangent is pi instead, okay? And also it is odd function, right? It is an odd function, tangent is odd. Okay. All right. Now let's just try to draw the graph. All right. Graphing tangent x. Okay. Graphing tangent x. As you can see, all right. So taking from special values of x. All right. So you can see that you can find the sine, cosine, and take the ratio. We have done this. All right. So we're not going to do this one anymore. All right. So negative pi over 2. At the angle negative pi over 2, cosine negative pi over 2 equals what? Equals cosine pi over 2. It's an even function, right? So this would be what? 0. Cosine is 0. So tangent is going to be undefined. Yes? Tangent is going to be undefined. Similarly, you can find this value is negative √ 3, and then so on, right? So you got all these. So this one is undefined, and some other values. You can use a calculator to find these values. Now, then you can just connect, find all those points and connect them. And you will got something like this one. Okay? So from negative pi over 2 to pi over 2 is something like this. Okay, as you see that this is negative 3.6, and this becomes really, really, really large as getting closer and closer to what? Well, pi over 2. So, for instance, when it is 1.56 positive, right, it's getting about 100, right, 92. So it's really, really up. So you have these vertical amplitudes, right? So you have that. Okay, so and this curve looks like this one, and it has a period of pi, so it will repeat after every pi, right? So this one centered at 0, next is centered at pi, this centered at negative pi. Yes, and then this is going to repeat. Okay. So this is going to repeat. You may also want to draw one using GeoGebra, right? Okay, let's just draw one in GeoGebra then, right? It equals what? Tangent of x. You see this? Yeah, and it looks like this one. Okay, so which is similar to ours. Which is similar to ours. It has this shape, right? It has this shape. And then variations of tangent x, all right? So the general form of tangent function is given by this, which can be rewritten in this form, right? Similar like a sinusoidal functions. Stretching or compressing factor is absolute value of a is the same. All right. Period is a pi over absolute value of b. All right. It's not 2 pi now. All right. So it's pi. The phase shift is still c over b. Vertex shift is still d. Right. Okay. Now the vertical asymptotes are given here for case and integer. Okay. Now for this one, there is no amplitude because it shoots to positive infinity, right? It shoots to the limit. Okay, so this is some variations of tangent x. The stretching and compressing factor, the phase, the period, the phase shift, the vertical shift, vertical asymptotes. The vertical asymptotes is where this x is not defined, right? But for this one, the general one is given here, all right? So we need to have this formula. I need to have this formula. Okay. All right. All right, let's move on to the next. All right, next slide. Are you ready? Okay. Okay, so let's consider this graphing. All right, graph one period of the function y equals -2 tangent pi x plus pi minus 1. What about this, right? So using GeoGebra, it's pretty easy, right? So it's pretty easy. Just type in those functions. We can get this. We can get them, right? So it's very easy. Okay. All right, let's type the function here. All right, it is -2 tangent pi times x plus pi minus 1. Okay, it is something like this. Okay, it is something like this. Now you can just see how it looks like, right? So for this one, the period is what? We're going to determine the period, right? The period is pi over pi, that's 1. I believe that's 1, right? So and so on. Okay, let's determine the values here. Right? It's easy to graph it in GeoGebra. Just type in and everything will be good. Right? For this one, y equals -2. -2 tangent pi x plus pi minus 1. All right. So the amplitude, but not the all right, let's do this one. The stretching factor. Now this one is a stretching factor is a, okay. Similar to the sinusoidal functions is absolutely equals to. Now this one is greater than 1, so it's stretching, okay. And then the period is pi over square root of b, pi over absolute value of b. Come on, dude. Should not move this. Okay, pi. Okay. Okay. The period over absolute value is 1. All right. And the vertical shift, right? D is -1. The horizontal shift, phase shift, right? The phase shift.
Would that be 1, 2?
That would be, okay, have to be careful here. All right, so you need to be careful. You need to write this one in this form first, right? So let's write this one in this form first. Everything else is easy, but here is -2 tangent I -1, right? But this one needs to be, this one is not in this one, the form of this. Is this the form of the rewritten one? We have is this form or not?
Don't you have to do minus 1?
Yes, exactly. All right, so you have to do one more step, right? It's -2 tangent I x minus 1. Now everything will be clear, right? So -2 pi z. The phase shift now is what?
-1.
That's -1. The shift is -1. Okay. Okay, all right. I think that's already time, and we have to stop here. All right. See you there.